Okay, let's dive right into this explainer. Today, we're unpacking a massive shift in how web apps actually talk to our computers. For the longest time, the browser has been kind of like a cage, but that's changing fast. To really get our heads around this, I want you to picture something a bit unexpected: a grand Victorian library right in the heart of London. Just imagine it: towering oak bookshelves, that distinct smell of old paper, and a vibe where absolute quiet focus is the law. Code craftsmanship is literally the only thing that matters here. Inside, we've got Margaret, this brilliant senior engineer, and Timothy, her eager junior counterpart. And through their story, we're going to explore a huge leap in modern web dev, breaking out of the browser's old constraints using the File System Access API.
So our story kicks off with a frustration I guarantee we've all felt. Timothy opens his local downloads folder and just lets out this heavy sigh. Look at this mess. Diagnosticlog.txt, diagnosticlog (1), (2), literally all the way down to 14. I mean, my own downloads folder is probably just as terrifying, right? Timothy was just trying to build a simple log export feature. Sure, it technically worked, but the user experience? Total garbage. Every single time someone clicked export logs, the browser whipped up a blob in memory and used that old HTML anchor download hack, basically a fake invisible click. If you updated the log and exported it again 10 minutes later, the browser didn't care. It just dumped a brand new copy, piling up duplicate after infuriating duplicate.
Well, Margaret took one look at this disaster zone and asked the obvious question: Timothy, why on earth aren't you just overwriting the original file? And Timothy? He explained his hands were tied by the walled garden. Now, we know this concept. It's that strict security constraint where the browser operates in complete isolation. And hey, it's there for a really good reason. It stops sketchy websites from reading our private files or quietly installing malware. It's a fortress. But because of this massive thick wall, every time Timothy triggered a download, the browser treated it like a completely isolated, brand new event. It had zero memory of the last download, zero connection to the local disk, and absolutely no way to tweak an existing file.
So Margaret takes a sip of her dark roast coffee and she completely challenges his fundamental assumption. She asks him if the browser is truly still an impenetrable walled garden. Or, and this is key, if Timothy had just stopped checking the gates. This brilliantly illustrates the whole paradigm shift we're talking about today. She dropped this incredible quote on him. She said, "The anchor download attribute was a great hack for 2014. But you're treating the browser like a simple document viewer. What if we treated it like a native desktop application?" I mean, wow, it's such a massive mindset shift. Actually, think about how often we all do this. We default to old hacks, and by doing that, we artificially limit our modern apps.
To show him exactly what she meant, Margaret walks right up to the whiteboard and writes down one single, incredibly powerful method: show a save file picker. So the crucial point here is that this specific function is our gateway. I just love this approach. She's explaining to Timothy that instead of blindly chucking files over the browser wall and just crossing our fingers they land nicely in some messy downloads folder, we finally have a way to just ask politely. We can explicitly prompt the user, giving them total control to securely choose exactly where that file lives on their hard drive. Just by asking, that entire dynamic between the web app and the OS completely flips. Let's break down how this actually builds into a sleek, elegant process, because the mechanics are beautifully simple. First up, we ask the user for explicit permission. We're basically unlocking the gate using a standard, familiar OS dialog. Once they say yes, magic. The operating system hands on JavaScript what's known as a persistent file handle. As Margaret explained with a grin, the second we have that handle in our code, the wall comes tumbling down. Next, we open a writable stream, which, by the way, is way more efficient than hoarding all that data in memory. And finally, we just write. We pipe our data straight to that exact file on the local disk. No more endless, cluttered duplicate files, just precise, native-level saving.
But, okay, if you're a seasoned dev, your alarm bells are probably ringing right now. You've spotted the catch. Timothy asked a fantastic question. And honestly, it's the exact same question I'd be asking. Wait, what if a user is on Safari or Firefox? Do they actually support this yet? And there it is, the ultimate reality check for modern web dev. Whenever we stumble across a shiny new API that promises to fix all our problems, we always have to pause and look at the actual user landscape. We're living on the bleeding edge here, and as we all know, the browser ecosystem is never, ever 100% uniform. Now, what's really fascinating about this current ecosystem is the stark divide it shows. As Margaret pointed out, this is just the harsh reality of the bleeding edge. On one side of the ring, you've got Chromium-based browsers, your Google Chromes, your Microsoft Edges. These engines are all in.
They robustly support the modern API, handing out those magical persisting file handles left and right. But on the other side, Safari and Firefox. For them, strict privacy boundaries are the absolute top priority, which means that security wall, it is firmly up. They flat out refuse to hand out file handles to web apps, meaning if you're on those browsers, you absolutely still have to rely on the old legacy download patterns.
So what does this mean? Do we just let the app break for half our users? Do we throw up some ugly error message? Margaret shut that idea down instantly, only if you don't check the gates first. The absolutely critical step here is feature detection. Before your code does anything else, you tap into the window object and explicitly check, hey, does this browser actually support this API? If yes, awesome. Fire up the file picker, grab that modern file handle, and go to town. But if it's not supported, your code just gracefully falls back to the old Anchor download hack. By checking the gates first, you get to ship these amazing new features to the users who can handle them without breaking the whole shebang for everyone else.
Taking all of this in, Timothy goes back and completely scraps his old logic. He wires up strict feature detection and rolls out the new streaming architecture for compatible browsers. And let's just look at the results, because the difference is literally night and day. The legacy way, clunky, silent downloads, zero control over where the file goes, and that mountain of 1.txt clutter we all hate. But the modern way, an absolute revelation. When Timothy clicks Export Now, a native Windows Save dialog pops up. He picks his exact folder. 10 minutes later, the data updates, he clicks Export again, and no prompt, no new duplicate file. The JavaScript engine securely streams that fresh data directly into the exact same file handle, cleanly overwriting it. Just elegant, professional, and honestly, perfect.
By embracing feature detection and really leveraging the File System Access API, Timothy totally bridged the massive gap between his web app and the operating system. He brought true native IDE capabilities right into the browser, and he did it without breaking a single thing for anyone on an older setup. Which brings us to a final thought for today's explainer. Now that this walled garden finally has a gate, and we can safely tap into the local disk, what true native capabilities are you going to build next? The tools are right there, just waiting for you to create something incredible. Thank you so much for hanging out with me for this explainer, and I'll catch you next time as we dive into more awesome tech.